so if you are on page 78 in your books, this is the first set of properties. These are properties that we would have learned in Algebra 1. So these are not on your handout. I'm about to give you some handouts, but these are ones that we learned in Algebra 1. Identity. If you add 0 to anything or multiply 1 to anything, the identity does not change. And so the identity properties say A plus 0 is A times 1 is A. Inverse property. If you add inverses, you get 0. If you multiply inverses, multiplicative inverses or reciprocals, you get 1. That would be your inverse property. Commutative property. This is where it's saying with addition and multiplication that order does not matter and you can change the order. Associative property. This one says with addition and with multiplication you can change your grouping. All right, so commutative is order, associative is grouping. And then distributive property, we're familiar with that one. If you have something multiplied to a group that has a addition and subtraction inside, then you can distribute that multiplication through to the rest of the group. Now, a couple of terms that you're going to see when we start doing these proofs. One of them is just simplifying. So when you combine like terms, that is just simplifying. All right, so on your handout, these are in the next, this is like in the next page, half page or whatever, in your book. These are in your books, but they're not listed in this order. And so on your handout, I have them listed in this order. I'm going to give you a few minutes to write them down, and then we're going to talk about them because I don't want you just writing while I'm talking. Properties. These are basic properties that we learned in algebra, okay? So when we start going through these algebraic proofs, you are really just giving me the steps of how you're solving the algebraic equation. And then you are telling me why you can do what you are doing. All right. And so the first 4 properties are just the rule that whatever you do to one side, you do to the other. That's what those 4 rules are. Addition, property of equality. If you have 2 things equal, you can add the same thing to both sides and it keeps it equal. Same thing with subtraction, multiplication, division. That's what those 4 properties are telling you. If you have an equation, whatever you do to one side, you can do to the other. All right. Distributive property. We already talked about this. Distributive property is if you have a number on the outside of a group that has addition or subtraction, you can distribute the multiplication through. Substitution property. If something equals another thing, you can substitute. This is true in sports, right? You substitute players for players, positions for position. Anywhere in an equation, then A can be replaced by B, okay? Reflexive property. This seems intuitive, but we are going to use this when we get to proofs with angles and segments. Any number equals itself. Okay, that's obvious. All right, symmetric property. You will use this sometimes if it says solve or prove that x equals 3. And then you get to the end of your proof and you have 3 equals x. It is very detailed, meaning if you have proven that 3 equals x and they ask you to prove that x equals 3, you have to actually flip it. And you have to tell me, well, why can you flip it? The symmetric property says I can flip the order if it's an equation. And then transitive property. This is like the law of syllogism. If A equals B and B equals C, then A equals C. All right? And so what we're going to do is we're going to go through some algebraic problems and we are going to explain why we can do what we are doing. All right? One more property that is not there is trichotomy property. For any 2 real numbers A and B, exactly one of the following is true. They either equal each other, A equals B, A is less than B, or A is greater than B. Those are my only options when I'm given 2 numbers. They either equal or they are an inequality, with A being larger or A being smaller than B. All right, so let's look at the example in the book, just naming the property. Example 1 in the middle of page 79 in your book. Name the property that justifies each statement, all right? It says 5s equals 60. Now in our book, they just have multiplication, they don't have division, because by definition, division is just the multiplication of the reciprocal. We're actually going to use the term division with our assignments here. So from 5s equals 60, they got s equals 12. What did they do to both sides? What did they do to go from 5s equals 60 to s equals 12? What did they do? They divided by 5. What property tells me I can do that? Well, if you look at your sheet, the division property of equality. Division property of equality tells me I can do that. Look at the next one. If p minus 7 equals 10, then p equals 17. What did they do to both sides there? They added 7 to both sides. Everybody see that? They added 7 over here and got p. They added 7 over here and got 17. Addition property of equality tells me I can do that. 2x plus 3 equals y equals 5x minus 7, then 2x plus 3 equals 5x minus 7. What did they do here? This should remind you of one of our deductive reasonings. If 2x plus 3 equals y, if y equals 5 equals 7, then 2x plus 3 equals 5 minus 7. It's the transitive, or law of syllogism, right? So it's like the law of syllogism. This is a transitive property when it comes to equality. This is transitive. If A equals B and B equals C, then A equals C. This is the transitive property. There are times when you could use substitution here. So I have seen people use substitution in this case as well. They said, well, y equals 5x minus 7, so they substituted in here, all right? With transitive property, it's important that it's in that order, though. And so if it's in this order, A to B, B to C, A to C, they're typically going to use transitive. But actually on a proof, I would take substitution here as well. Because you did not change anything else, you just substituted y for what y equals. And so I would actually take substitution here as well. All right, 4t minus 1 equals u. T equals 8u. Then 4 times 8u minus 1 equals u. There's only one you can use here. What did they do here? They said that 4t minus 1 equals u. They told us that t equals 8u. What did they do here? They substituted. They replaced the t with the 8u. This is substitution. So while this I would take either substitution or transitive, this can only be substitution here. Only substitution. And so you do need to know this definition. It's in your book. It's in your book, bottom of page 79. A proof is a system of reasoning or argument to convince a person of the truth of a statement. Okay, this is a proof. All right. So in a formal proof or a 2-column proof, you are going to have a list of statements or steps in that proof. And then you are going to have a list of reasons. So on the left-hand side, you will have your statements. And on the right-hand side, you will have the reasons why you can make these statements. Certain things that you can use in proofs. You can use properties, definitions, postulates, and theorems. Remember, postulates and theorems, that term comes from chapter 1. When you start a proof, it will give you a statement like this. It'll either give you an if-then statement, or it'll say, given this, prove that. All right? When they say given this, they have actually handed you your first step in the proof. If they use it in an if-then statement, the hypothesis is your first step in your proof. In this case, they gave us an if-then statement. If negative 3 times x plus 6 equals 6x, then x equals negative 2. All right, so what is my hypothesis of this if-then statement? That left side, right? And so my very first step for a proof is to write down my given or my hypothesis. So my first step here is negative 3 times x plus 6 equals 6x. That is my first statement. It will always be your first statement because it will always be given. Whatever they handed you is your first statement. The reason you can tell me that is because it was given to you. All right? So your first statement will always be your given statement. They give it to you, you write it, and you say given. That is given to me. All right? So everyone should get the first step of their proof, always. So then algebraically, with an algebraic proof, you're literally just looking and saying, what would I do next algebraically? So what would you do next algebraically? Prove it. So they don't want us to evaluate. If they had said evaluate this for 2, that's what we would do. They want us to prove it. So the very last thing you're going to do is tell me that x equals negative 2. What you want to do is you want to concentrate on solving it as though they have not given you the answer. All right, so if you had not been given the answer, what would you do to solve this? You would distribute, okay? And so that's what we're going to do. We are going to distribute. So what does it look like when I distribute? Well, I'm going to say negative 3 times x and negative 3 times 6. Well, why can I do that? You just told me. The distributive property tells me I can do that. And so I am going to tell you that the distributive property is the reason I can do this. All right? Now, in an algebra problem, my goal is to get my x's to one side and my numbers to the other, right? And so I have an x on both sides of this equation. I have an x over here and an x over here. Now, if you already have an x by itself, logically, I would move these over, okay? So I am going to do what to both sides of this equation? I'm going to add 3x. So I am going to say that I have negative 3x minus 18 plus 3x. And that is going to equal 6x plus 3x. Why can I add something to both sides? What property tells me that? The addition property of equality. All right, addition property of equality. All right, now, this next step is one that I said that you will sometimes see as simplification. You're just simplifying or combining like terms here, okay? So you can tell me simplify. You can say combining like terms, whatever you want to say to indicate that you are just combining those two that are alike. So on the left-hand side, if I combine these, I actually get 0. Those are actually reciprocals. So you could actually say inverse property for that. Or if you're just going to combine like terms on both sides, you can say simplify. The left-hand side is going to simplify to negative 18. The right-hand side is going to simplify to 9x. So I'm just going to say simplify, or you can tell me combining like terms. Whichever one you want to tell me why you did what you did. All right? So algebraically, what would be my next step here? I'm going to divide both sides by what? By 9. And so I'm going to say negative 18 divided by 9 equals 9x divided by 9. Why can I do that? Division property of equality, right? So division property of equality tells me I can do that. All right? The next step is once again simplifying. That's all I'm doing here is I am simplifying those. What is negative 18 divided by 9? Negative 2. What is 9x divided by 9? X, right? It's 1x, yes. And you don't have to write the 1, but it is 1x. Have I finished? Have I done what they told me to do? What did they tell me to do? They told me to prove that x equals negative 2. What did I prove? That negative 2 equals x. It has to be exact. This is a proof. This is what drives people crazy about proofs. It has to be exact. I have to flip-flop those. There's a rule that tells me I can. What is it? The symmetry rule, yeah. So if you look at the symmetric property, it says A equals B, B equals A. And so at this step, I'm literally just going to flip it. X equals negative 2, and that is the symmetric property. So your biggest downfall is going to want to be jump steps, all right? You're not going to want to show me this is why I can do, this is why I can do, this is why I can do. They start out with algebraic proofs because it's something you're familiar with. Hopefully this is not a difficult algebra problem to solve, all right? So they give you just the process of logical thinking. This whole section is about algebraic proofs because they just want to get the logical arguments order in your brain and how to argue this particular step. I can do this because of this. I can do this because of this. All right. And so they're not using difficult ones, but they want you to just walk through the process every step of the way. So I will tell you that on your handout, they jump over the simplify steps. All right. On your test and quiz, I am going to throw in the simplify or the substitution steps where you have to say, okay, I am simplifying here or I am substituting the fact that 2 minus 1 is 1. All right. So while they jump over it, I'm going to write it in there just so you know that those 2 steps are in there. So this is a really short one. They say, given 4x minus 1 equals 27, prove that x equals 7. And they actually gave you the steps. So the first step is very easy. That is your given. They wrote it down, given. What did they do from step 1 to step 2? They added one, right? And there's actually two steps in here. The addition property of equality, and they simplified. So this is where on my test, I would have a second line there where you would say, you would have 4x minus 1 plus 1 equals 27 plus 1. That's your property there. And then you would also have simplify. They did both of those in one step. So for this one, they divided both sides by what? 4. So I would have a line here. 4x divided by 4 equals 28 divided by 4. So you would have the division property of equality. And you would have simplify there. They did both of those steps in that one. If we're giving you this on a test, you would have 5 blanks there. So you would have 5 blanks. This would be 5 points. And you would have a point for every blank there. Ones. If you'll recall from the first chapter, this means that y is between x and z. All right, so if you remember from the first chapter, that notation tells you that y is between x and z. All right, and so we're going to use that information in this proof. So the first thing we're going to say is well, what is given to me? We are given the figure xyz and that xz equals 35, all right? So that's exactly what we're going to tell them. We're going to say, I have the figure xyz, right? And they also told me that xz, or the length of the segment xz, is 35. That is what they told me, given. And then they gave me this information. And so the reason I know that is given. Now, from the first chapter, if something is between 2 points, remember we did this process, then that means you can add up the shorter pieces to get to the whole, right? So remember, if it's between the 2 shorter pieces, add up to the whole piece. And so now I can make the statement that looking at this, I can say, well, xy plus yz equals xz. All right? So I know that xy plus yz equals xz. Why do I know that? Because the definition of between tells me that. That's how we were able to do those. So if you go back to chapter 1, we learned the term between. And that term told us you could add up the two pieces and get the whole. So this reason is the definition of between. So this tells me they told me in my given it was between. I know what between means. It means that those two pieces add up to the whole. And so I have to actually say that before I can just set these up and go. All right? Now that I know that, I can actually take these and put them in for this. What is that reasoning? Why can I take those in and plug them in on top of it? What is that? What am I doing there when I do that? So if I take what I know to be true, xy, that is 4b plus 3, and I take yz, 7b minus 1, and I take xz, 35. Why can I do all of that? What's the reason behind that? What is that rule? It's one of my rules. What rule tells me I can do that? What did I do? I replaced it. What's another word for replace? Substitution. All right? Substitution. Substitution there. All right? So I substituted that in. Now I just have an algebraic one. That's all I have, right? So I can simplify this. What can I simplify there on the left-hand side? What can I simplify? My like terms, 4b and 7b, give me what? 3 and negative 1, give me what? All right? And so that is just simplifying. All I did was simplify there. What's my next step? Algebraically, what am I going to do? Subtract 11b plus 2 minus 2 equals 35 minus 2. That is just subtraction property of equality. All right? My next step, I'm going to simplify again. The left-hand side, I have just what? The right-hand side, I have 33. That is just simplifying. What's my next step here? Divide. Divide both sides by the 11. So I'm going to have 11b divided by 11 equals 33 divided by 11. That's division property of equality. And my final step here, what is it? Simplify or substitute, whatever you want to use. B equals what? 3. That is simplifying or substitution. You're substituting what they actually equal. All right. All right, from your handout, look at number 3. Number 3. And again, I am going to throw some extra steps in here because I feel they're actually skipping some steps here a little bit sometimes. All right. So number 1, it says negative 9, 2x minus 3 equals 63. Why can they tell me that? Well, that was given to me. Given, that's easy. What's my next step here? Distribution. So they just multiplied negative 9 times 2x, negative 9 times negative 3. So this number 2 would be distributive property. This next one is going to be, I would have 2 steps on a test here. All right. What's my next step? What do I actually need to do? I need to subtract 27. So I have 18x plus 27 minus 27 equals 63 minus 27. So I actually have the subtraction property of equality and I have simplify or substitution. I will take either simplify or substitution. You're substituting in what those equal. All right. What's my last step here? I have negative 18x equals 36. What do? Divide both sides. And again, on your test, you need to add this little guy here. Divided by 18 equals 36 divided by 18. That is division property of equality. And they also simplified or substituted in. Easy enough. All right, so on yours, go ahead and finish the